In this question, it is given that let fx equal to box 2x square plus 1 and gx equal to this thing, where box t denotes the greatest integer less than or equal to t, then in the interval -1 to 1, the number of points where f naught g is discontinuous is equal to. If you see this function carefully, it is clear that ignoring x equal to 0, it is a odd function. For x equal to 0, we can discuss separately, because g minus x will be minus 2x minus 3 if minus x is less than 0, minus 2x plus 3 if minus x is greater than 0. That is, I can say minus of 2x plus 3 if x is greater than 0, and minus of 2x minus 3 if x is less than 0. Hence we can say g minus x equal to minus gx for positive or negative both the values. From here it is clear. The benefit of using that gx is odd function, will not have to discuss the continuity in the whole interval -1 to 1, will be requiring to discuss the continuity only in 0 to 1. Agreed. At 0, we'll be checking the continuity separately. Hence, we will be checking the continuity of f naught gx in the open interval 0 to 1. Number of points of this interval at which f naught gx is discontinuous, same will be the number of points of the interval -1 to 0. Hence, we will have to deal with only one interval. X equal 0 will be taken care of separately. Fx is clearly a even function. Hence, I can say that f naught gx, which will be f gx, which will be box 2 into hence, even if gx is odd function, f gx will be still even function. Therefore, keeping the concept of even function in mind, will not have to discuss the points of discontinuity in the whole interval. It will be sufficient to discuss the points of discontinuity in the interval 0 to 1 only. X equal 0 will be discussed separately. If f naught gx is discontinuous at n number of points in this, then n points will be there in -1 to 0. Hence, total number of points of discontinuity in these two will become 2n, and x equal 0 will be seen separately. Hence, now let us discuss the continuity only in the interval 0 to 1. For x more than 0, clearly f naught gx becomes 2 into 2x plus 3 whole square plus 3, that is equal to 2 into 2x plus 3 whole square plus 3. And now we'll find when x lies between 0 and 1, how many integral values this can take. This whole will be discontinuous at all those points wherever this is an integer. Just for knowledge, I am telling you, at -3/2 it is a continuous function because it has local minima. But this thing I have told just for knowledge because we are dealing in the interval 0 to 1. Now, if x lies between 0 and 1, 2x will lie between 0 and 2, 2x plus 3 will lie between 5 and 3, 2x plus 3 whole square will lie between 25 and 9. 2 into 2x plus 3 whole square will lie between 50 and 18. Hence the possible integral values of this are 19, 20 and so on up to 49. And every equation will give you only one value of x because we have supposed that x is positive. Hence from here you will be getting 31 number of values of x. And as I told you in the very beginning, similarly in the interval -1 to 0, there will be 31 more values of x will be getting. And lastly, we have to check the continuity at 0 because I told you in the very beginning 0 will be taken care of separately. Limit x tends to 0 plus f of gx. When x is slightly more than 0, keeping this thing in mind, we can say the value of gx will be slightly more than 3. Hence, if x is slightly more than 3, we know that the interior part is slightly more than 19. Hence, the answer will be 19. Similarly, when x is slightly less than 0, this thing implies that the value of gx will be slightly less than -3. And when x is slightly less than -3, the value of this will be slightly more than 18. Hence the value of this will be slightly more than 19. Therefore, in this case also, f naught gx will be 19. And for x equal 0, gx will be 3. And when x is 3, the value of this is 19. Hence, f naught g 0 is 19. Hence, the function is continuous at 0. Therefore, total number of points of discontinuity becomes 31 plus 31, that is 62.